Hi folks, in chapter 4 we looked at how to write chemical formulas for certain types of compounds, and then we used chemical equations to represent reactions. So in chapter 5 we're going to be studying certain types of reactions in more detail. And we're going to start off with the synthesis and decomposition ones. And this video is going to deal with synthesis reactions. Okay, so first I'll start off with a definition. So synthesis reaction is one in which two or more reactants react to form one single product. Okay, so these reactants can be elements or compounds, but the product is always going to be a compound. Okay, and since we're going to use chemical equations to represent these reactions, please make sure they're always balanced before moving on. Okay, so let's take a look at a few examples here. So example 1 says that under high temperature and pressure, nitrogen and hydrogen react to produce ammonia gas. Okay, so I'm actually going to have you stop the video and work on this problem. Now, nitrogen and hydrogen you should be able to deal with. Now, ammonia we have seen before, but it certainly doesn't have a name that allows us to easily determine the chemical formula, so I'll give that to you. Ammonia's formula is NH3. Okay, so I'll now ask you to stop the video and take a couple of minutes to solve this problem. Okay, so we're back. Let's try to write down a chemical equation here. So we've got nitrogen and hydrogen as our two reactants, but hopefully you remember that these are both diatomic molecules. So they don't exist as just single nitrogen or hydrogen atoms. They exist as diatomic molecules. So nitrogen is actually N2 and hydrogen is going to be H2. So remember to refer to that list if you're ever not sure. Okay, and then these two reactants react to form the single product ammonia, which is NH3. So now that we have our skeleton equation, we just go ahead and balance it. So we see that nitrogen is not balanced on either side. So I've got 2 here and only 1 there. So I'm going to add my coefficient of 2 to balance out the nitrogens. And now let's look at the hydrogens. We've got 2 on the left and 6 on the right. So in order to get 6 on the left, I just need to put a coefficient of 3 in front of my hydrogen. Okay, there we have it. 2 reactants form 1 product. Nice balanced equation. Okay, let's move on to example 2. So here we have aluminum and oxygen yield aluminum oxide. Okay, so here you should be able to come up with all the chemical formulas. So again, I'll ask you to stop the video and work on this problem for a couple of minutes. Okay, we're back again, and so here, well, we've got aluminum, so we know that's just Al. Okay, and now we also have oxygen, but oxygen is yet another one of our diatomic molecules. So we'll have to write that as O2. Okay, now for our product, well, aluminum oxide, we see a metal, oxygen a non-metal with the IDE at the end, so that means it must be an ionic compound. So let's get our periodic table, and we see that aluminum has a charge of +3 and oxygen has a charge of -2. So we'll use that to write the chemical formula. Okay, so here +3 and then this is -2, and so we're going to need to get a neutral compound. So the lowest common multiple between 3 and 2 is 6. So we need 2 aluminums and we need 3 oxygens. Okay, so our product is going to look like Al2 and then O3. Okay, so let's now balance this equation, since clearly it's not balanced. The aluminums are not, so we tend to start with the metals. So if we balance the aluminums, you see 1 here and 2 there. So we're going to put a 2 in front to balance the aluminums. And now let's check the oxygens. So 2 on the left and 3 on the right. Okay, so again, they're not multiples of each other, so we're going to have to figure out that we're going to again need to work with the lowest common multiple. We're going to need 6 on either side in order to make this work out. So I have 3. I'm going to put a coefficient of 2 to get my 6 oxygens on the right, and then a coefficient of 3 to get my 6 oxygens on the left. So now we've balanced the oxygens, but of course we see that the aluminums are no longer balanced, because now I have 4 on the left, 4 on the right, but only 2 on the left. So that means I'm going to have to change this coefficient to a 4. So for aluminum, my final answer will be
4 aluminum plus 3 oxygen yields 2 aluminum oxides. Okay, there we have it. So we're going to move on to example 3. We'll do this one together here, and we'll see that it's a little different. So it tells us that lithium and chlorine are the reactants in a synthesis reaction. Okay, write a balanced equation for such a reaction. Notice here they don't give us the product. Okay, so we're going to have to see if we can figure out what the product should be in this reaction. But notice here we have lithium and chlorine. Okay, these are both, this is a metal and a non-metal, so it makes sense that this should form an ionic compound. Since we know there's going to be only one compound on the product side, since they tell us it's a synthesis reaction, it makes sense that it should be lithium chloride. Okay, so let's take a look at our periodic table, and we see that lithium has a charge of +1, and the chloride ion will have a charge of -1. Okay, so +1 and -1, meaning we only need one of each in order to get our neutral compound. Okay, so reactants are going to be lithium plus chlorine. Don't forget, chlorine's another one of those diatomic molecules. Okay, so it's actually going to be Cl2, and then our product is going to be, we assume, lithium chloride. Okay, so no subscripts because we just need one of each to balance them out. And now we just have to balance our equation. We see the chlorines are not balanced, so I'm going to have to add a 2 here to balance the chlorines. And then because I now have 2 lithiums, I'm going to have to add a 2 in front there. And there you go. You have your balanced equation.